Good morning to all. This is Professor R. Sudha, Assistant Professor, Department of Electrical and Electronics Engineering, and M. Visalakshi, Assistant Professor, Department of Electrical and Electronics Engineering from Thandai Periyar Government Institute of Technology, Vellore. Welcome to e-learning class, and today's topic from the subject Protection and Switchgear. So in this video lecture, we are going to see the introduction from unit 1. So before moving to the introduction in unit 1, what are the basic terms, symbols used in protection and switchgear? And it is this subject is basically from the concepts of power system, transmission and distribution subject. So many concepts we all come under from the power system analysis as well as transmission and distribution. So here these are the basic terms and symbols used in protection and switchgear. So we are all very familiar with some of the symbols used in electrical systems, means transformer, generator, delta connection, star connection, transmission lines, fuse. Okay, some other than is two winding transformer. So this representation is two winding transformer, and this is your, it is also represented like this also. And generator we all come across, so it will be like this, will be like this. And bus, transmission line, delta connections, star connection or Y connection, static load, current transformer, it will be shortly represented by CT, voltage transformer or potential transformer, capacitor, circuit breakers, and it also represented by the another symbol. And this is your fuse, surge arresters and disconnection. So passing through your switches, this is your disconnect. And next, these are the figure representation of relay, circuit breaker, bus bar and surge arresters, fuse. So these are all the diagram representation, and we can easily identify. So this is your relay, bus bar, circuit breakers, relays, switches, circuit breakers. So these are the some. And so some of the concepts we will be seeing in this video lecture. Basic concepts, transformer we all come across from your BEEE. So it is a static device to step up and step down the voltage level. And breakers, circuit breakers, mainly to interrupt fault current, to isolate faulted equipments and to energize the equipment. Next is your isolators, mainly to isolate the fraction of electrical circuits required and also to open the circuit in no load condition. And next is your relays. So to detect the fault and initiate the operation of circuit breakers and also to energize the EMF producing from the magnetic field. And next, bus bar, to connect the high voltage equipments at electrical switch yards. And next is your reactors, mainly to compensate for the charge current or to limit the fault current. And next is your groundings or earthings. It is a reference point used in our electrical circuit where the voltage is to be measured and also to maintain the equipments safely. And next is surge arresters. It is to protect the equipment from over voltage transients or lightning strike. And next is your switch gear. So coming to the switch gear, it's a integrated components and for controlling, regulating, protect and the control flow. And the last one is your regulators. Regulator, it is a voltage, current, phase angle to maintain the voltage of power source within the limit. And next is your fuse. So we are all familiar with the open and closed type. So it will be allowing a passage of normal current and as well as excess current only for the short periods. And the next is our topic protection and switchgear systems. So mainly to protect a person and primary electrical power equipment from the fault, and is also a combination of switches, fuse, circuit breaker to protect or control the electrical equipment. So this is your components used in our power system protection. So relay, what we saw here is the system quantities are normal or abnormal, and here potential transformer or current transformer used. So here it is your transformer. So it is to change the electrical quantities based on the level what we are using. And a circuit breaker, a quantity or normal, no signal is sent to the breaker, or if the quantities are abnormal, signal will be sent to the circuit breaker to trip the circuit. So these are the components. And next is your protection schemes. So main objective of this is to keep the power system stable by isolating only the components under the fault, or device to protect your power system from the fault or protection device. So here, before moving to the protective zone, we have to know the concepts of switchgear, and that is protection and switchgear. So what we, as we told already, switchgear, it's a combination of electrical disconnect switches, fuse, circuit breakers to control and isolate the equipment, and also to de-energize the equipment to allow the work to be done. And it is an apparatus and method used for switching, controlling, protection of electrical circuits and equipments is your switchgear and protection. So mainly to control, protecting of our electrical circuits. In normal operation of our power system, in switchgear, fuse, circuit breakers, relays, etc. are permitting to switch off or on the generator, transmission lines, distributions and other electrical equipments. So next is our protection zone, protective zone. So here protective zone, mainly the name represents to safeguard particular area. If any fault occurs in any zone, only the circuit breaker in that particular zone will be tripped off. Suppose this is my zone 1 and this is my zone 2, which is connected with the bus bar and circuit breakers. Where the fault occurs, the particular of that circuit breaker, means particular zone will be tripped off if any fault occurs. Okay, so from your circuit diagram, this is your generator, transformer, bus, transmission line and motor. Okay, so this is what your components used in your protective zones. So these are the categories used in protective zones. So what we saw in previous slide, same representations. It is represented by a separate unit generator transmission zones. This is your transformer, which is a reactor, and this is your line zone, and this is your motor zone, and here it is your bus zone. So both the circuit are same. The thing is they have represented with a separate zone. Where the fault occurs, that part will be tripped off using your circuit breakers. So this dark line representation will be a bus. So from here to this here, our circuit representation is your bus zone, and here it is your motor, generator, transmitting zone. Okay, so these are some of the categories of protective zone. So in next video lecture, we will be seeing the details of protective zone, what are the categories of protective zone, how it is overlapping in power systems. Thanks for watching.